Good morning all. So in today's class we'll see one more problem on finding the solution where the roots are complex. So the question is, find the general solution of the following systems. So the first one is, we have dx by dt equal to 2 minus 3, then 3 to x. So the characteristic equation is given by, so that is determinant a minus lambda I equal to 0. So you will get 2 minus lambda minus 3, 3, then 2 minus lambda equal to 0. So that is going to give 2 minus lambda whole square plus 9 equal to 0. So this is in the form a square plus b square. So you will get 2 minus lambda plus 3i and 2 minus lambda minus 3i equal to 0. So that gives lambda equal to 2 plus 3i and 2 minus 3i. So those are going to be the characteristic roots. So your eigenvalues are 2 plus 3i and 2 minus 3i. So let us see the eigenvectors. So when lambda is equal to 2 plus 3i, so we need a minus 2 plus 3i x equal to 0. So this equation gives, so you will get 2 minus 2 plus 3i, then minus 3 varum 3, then 2 minus, again 2 then 2 minus 2 plus 3i x equal to 0. So upon simplifying, 2 will cancel off, so you will get minus 3i minus 3, then 3 and minus 3i x equal to 0. Okay, so now let us row reduce the matrix. So when you row reduce, so you are going to get okay, so you take the matrix minus 3i minus 3, then 3 minus 3i. So take R2 goes to I R2, so that will give minus 3i minus 3, so you will get 3, so I square is going to be minus 1 upon 3 varum, so that is multiple of 1 another, so you are going to get 0, 0. So take now R1 goes to R1 plus R2, so you will get 0, 0, then 3i 3. So that gives us the equation 3i x1 plus 3 x2 equal to 0. So put x1 equal to t, so you will get x2 equal to minus 3it by 3, so that is minus I t. So you will get the eigenvector x1 to be 1 and minus I. So the first eigenvector is 1 minus I. So now let us look at the second eigenvector. So when lambda is equal to 2 minus 3i, so when lambda is 2 minus 3i, we need a minus 2 minus 3i I x equal to 0. So that implies, so we are going to get the matrix So you will get 2 minus 3i varum, minus 3 varum, 3, then 2 minus 3i, x equal to 0. So that will give us the equation 3i minus 3, then 3 and 3i, x equal to 0. Again, upon multiplying, so take r1 goes to r1, r1, so that implies, so that will be equivalent to, so you are going to get the matrix, minus 3i, then 3 and 3i, again take row reduce, so take r1 goes to r1 plus r2, so that is going to give 0, 0, 3 and 3i. So we will get the equation 3x1 plus 3i x2 equal to 0. So take x2 equal to t, so you will get x1 equal to minus I. So the eigenvector is going to be again 1 and minus it varum, so minus I1. So the first eigenvector is 1 minus I and the second eigenvector is minus I1. And now let us write the general solution. So therefore x of t is equal to c1. So you have 1 minus I. So e raised to 2 plus 3it. രണ്ടാമത്തേത് c2. You have minus I1. E raised to 2 minus 3it. So that is e raised to 2t is common throughout. So you will get c1. ഇവിടെ നമുക്ക് cos 3t plus I sin 3t വരും. Then minus I into cos 3t plus I sin 3t. Then minus I into cos 3t minus I sin 3t. Then plus 1 into cos 3t minus I sin 3t. So now the real part of the equation is also a solution. So we will take the real part. So therefore the general solution is, so x of t will be equal to, so you will get e raised to, okay, c1 and c2 and inside, that will come inside. So c1 will be here, then c1 varum, then here c2, then c2 varum. Okay, so you have e raised to 2t into, the real part is c1 cos 3t, then I square is minus 1, so that will be again minus c2 sin 3t varum. Then രണ്ടാമത്തെ terminal e raised to 2t into, the real part is c1 sin 3t plus c2 cos 3t. So you have x1 of t equal to e raised to 2t, c1 cos 3t minus c2 sin 3t, then x2 of t equal to e raised to 2t into c1 sin 3t plus c2 cos 3t. These are general solution. So this is the case when the roots are complex. And now one more problem, so I want you to do this as an exercise. So please work out the problem in your notebook. So find the general solution of dx by dt equal to 1 minus 3, 3, 1, x. So kindly solve for this. So find the general solution of the system. So please solve for this one also. Thank you.